All right. So hello, everybody, and thank you for joining us in this webinar. Our topic today is blockchain for telcos. And I have with me Santiago Siri, who's an author, a speaker, founder of Democracy Earth Foundation, and founder of Crypto Political Party, as well as a recognized as MIT top innovator under 35. Santi and I have been discussing about blockchain and applicability for telcos for some time now. And we've been having very interesting discussions that we decided to open up and have it in public. So Santi, thank you very much for joining us. Do you want to tell us a bit more about yourself and also how you came about getting interested on blockchain?
Hi, Rui. I've been into blockchain for almost 10 years now. Back in 2011, I was already interested in the topic of virtual currencies, and that was when the paper written by Satoshi Nakamoto came into my attention. And since then, being Argentine, in Argentina we have a very high inflation economy with a very weak local currency, capital controls that ban access to US dollars. So all of those elements, being myself a young programmer, helped me get extremely interested in this technology. And throughout the last 10 years, I've been involved in different activist, political, technological projects that try to use technology to improve the quality of institutions. First with a political party back in the city of Buenos Aires that tried to use the internet to improve the quality of our democracy. And more recently with Democracy Earth, which is the foundation that I preside and that we research technology for digital governance. Throughout these 10 years, the evolution of Bitcoin and eventually the rise of smart contracts, Ethereum, and technologies that enable the creation of distributed trust without centralization, without authority, the principle of being able to transfer value anywhere around the world without needing personal private information about the sender or the receiver, with the ability to do it anywhere there's simply an internet connection, and by using cryptography to guarantee the privacy of that transaction. All of those elements became very attractive, became a tool for protecting my assets or my savings against a weakening local currency back when I lived in Argentina. And it allowed me to start building with a technology that can create networks out of the use of cryptography and enable a much more transparent and very secure systems of governance when I started working in that direction. The potential of blockchain technology is immense. It has been growing significantly, consistently over these 10 years, not without volatility. The value of Bitcoin has been steadily growing with huge run-ups where suddenly it can go from $100 up to 1,000 or from 1,000 up to 20,000. And then also big corrections where you can see correcting 90%, 80% after it peaks at a certain price. But nonetheless, every floor Bitcoin had throughout the years has been significantly higher than 2 or 3 years prior. And it seems to be a technology where, in a world where governments print money without any asset backing that printing, suddenly the ability to do cryptographically induced scarcity through the use of computation renders out of something like Bitcoin something that can be perceived as very valuable for the world markets, and Ethereum as a technology also promising the ability to enable, through the use of cryptography, more uses than just sending money online.
So one of the recurrent topics, at least when I talk with some people about blockchain, is people immediately associate blockchain with cryptocurrency, particularly Bitcoin. Some people believe that blockchain is actually cryptocurrency. And then the discussion about how to apply blockchain to different use cases or different industries is a difficult one. Can you explain us what blockchain is, and what's the difference between blockchain applied to different use cases versus blockchain applied to cryptocurrency?
So this is an ongoing debate. The crypto space is extremely ideological because, after all, when you're dealing with technologies of money, with technologies that grant access, that grants power, these networks inevitably also become political. So when you go deep into the forums, social media, and the environments where these technologies are being discussed, you will find among those different tribes. The main ones, I would argue, there is the maximalist tribe, the one that, to sum it up, believes there's only gonna be one coin to rule them all. And that usually tends to be, for maximalists, the idea of Bitcoin. But the problem is that Bitcoin itself, by design, from the conception that Satoshi Nakamoto had about that technology, is not Turing complete. It's not a blockchain that can execute a full spectrum of computations when a transaction happens. So that was a design choice to reduce the surface of attack of Bitcoin, make it a dumber, simpler machine, and avoid the risk of a transaction having malicious code, or a transaction that simply is negligent and can risk halting the entire network. So for that reason, Bitcoin is closer to a calculator than to a computer. In 2015, Vitalik Buterin introduces the idea of Turing completeness to blockchain-based networks, and he does so with a simple tweak to the idea where computations will be executed as long as these computations are funded or financed by gas. This gas is paid for with a cryptocurrency. So as long as there's some cryptocurrency backing the execution of a program, regardless of how well or badly written that program is, the program will stop executing once it runs out of gas. And this gas is usually provided by the users. Sometimes there are gas relays that can help companies subsidize the gas for their services, but no computation will be executed unless there's some crypto funding that computation. And that enabled Ethereum and other blockchains, but Ethereum is probably the main one in terms of activity, to generate an explosion of innovation around it, where you have over 250,000 tokens that represent different projects, that represent different assets. Some of these assets are purely digital and synthetic, and some of the assets have a correlation with a security in the real world, with legal backing, and represent real assets in the world. The Ethereum, I think it's one of the most interesting projects. It has been live, the mainnet, since 2015. And with smart contracts, we have seen systems for lending, systems for borrowing, systems for derivatives, systems for insurance. All kinds of financial instruments have been created in what is now known as DeFi, or decentralized finance, the name given to the larger movement of projects built on top of these protocols. And the interesting thing about DeFi is that you can borrow, you can lend, you can transact as you can do in the traditional financial world, but without the need of revealing your identity, protecting your privacy in a permissionless way, under a network that no single entity or government around the world can censor. And in that regard, holds tremendous promise for creating new avenues for transferring value over the internet, and for giving, at the end of the day, the end user more control, more sovereign control over his information, his data, and his activity online over the internet. It's, I would argue that blockchain is giving a new layer on top of the web and on top of all the other layers of the internet that grants that right to the end user of being able to have ownership over his or her data.
Yeah, I think, and that's I think a particular interesting topic when it comes to service providers. One of the biggest challenges of service providers is the fact that they require to identify their users and provide the identification of the users when they're accessing services. And at the same time, they're regulated, and there's data privacy regulations that they need to comply with. So there's the constant kind of challenge of protecting the user data, but you still require that user data to provide the services. So would you say that that's potentially one of the first applications of blockchain within the telco domain?
I would think so, yeah. And telcos are able to see the activity of users on a daily basis, and at the same time, they sit between the user's phone and the internet itself. And it's precisely in that space where these technologies can play a very profound role, redefining the way we control our data, or how we grant access to our data. The beauty of cryptography ultimately is based on the idea that we can carry secrets, that we keep secrets in our minds. The interesting fact about how cryptocurrencies work is that as long as no one else knows the seed phrase or the password behind your wallet, those assets cannot, or that the access to that information cannot be hacked or obtained by anyone, as long as there's enough computing power protecting the network as a whole, which is the case of Bitcoin and Ethereum. Until this technology that ultimately ends up empowering the end user, for every service that is out there, the traditional software architecture has been the client-server architecture. And the client-server architecture requires a relation of trust where the secret is not kept in my own head as a user. It is given to a server. Whenever we type a password, so the second server knows that secret, and I have that relation of trust with the server is tracking my activity, is tracking my data, and is ultimately owning my data. With decentralized networks, there is no relation between a client and a server. It is directly the user with the blockchain itself, and the blockchain is the layer that verifies with public keys that you are effectively the owner of a certain public key, but the verification of the ownership of that public key is done locally in the client, in your phone or in the wallet that you're locally using in your home computer or in your local home device, personal device. So you are not sharing this secret to a server which grants them some ownership to your data, but ultimately you have this control yourself. The challenge relies on that we have to teach users. Users are not used to interacting with online services this way. So it requires some degree of digital alphabetization regarding the knowledge of cryptography. There's still a lot to be taught about this topic to the general users, but there's a new generation of early adopters that are into crypto, that are into these technologies, and are starting to experience and perceive the web under a whole new lens. And for applications that have to deal with data, the possibility of granting the user the ability of deciding at the end of the day how much personal data I will reveal, and if I am able to preserve my anonymity in the maximum possible level, I can do it. Giving that option to the end user in an age where there's serious concerns about privacy around the whole world, and digital manipulation by social media and politics. I think that it's a very promising solution to tackle a problem that ultimately benefits the end user the most.
Yeah, and one of the concerns that many people have, and service providers also have in that sense, is, for instance, take the cryptocurrency. If you lose your wallet, you lose your currency, right? And
Yeah.
there's no way to recover it. Now, when you're a service provider, you're providing a service, so you granted the way to the user to control the service. What happens if the user loses that local identity system, and how can a service provider ensure that they maintain continuity of the services provided?
So that's a great point. Sorry, excuse me. There is a trade-off, right? Once you decide to take responsibility for managing your assets, sorry, your assets using this kind of technology, that's a big responsibility, because ultimately, if your seed phrase gets stolen, or you mistype your password in a phishing site, or your secret is leaked in any way, then a malicious player can take immediate control of your assets, and it can represent serious damage, because it is very hard, for not to say practically impossible, to undo that, to protect. There are some innovations now trying to use smart contracts as a way of enabling some possibility of reverting a transaction, but at the end of the day, you have to be aware that if you are deciding to take direct control over your assets using cryptography, there is no customer support that you can call, and so it is definitely something that requires a certain level of knowledge and capacity in order to be able to take that step in a way that you feel secure, and that you are aware that you know effectively what you're doing. So I would argue that probably it's not ideal to put absolutely everything in a hardware wallet hidden under your own passphrase, because you're putting the entire risk on yourself. And in that regard, there's obviously room for service providers of all kinds. We have seen in the last 10 years also a lot of onboarding technologies that serve as a middle layer between traditional banks and crypto, and a lot of services that try to reduce some of the risk of how the crypto primitives work. So I would say today that it's probably a safe strategy with crypto in general to diversify your holdings across multiple exchanges, multiple wallets, hardware wallets also, of course, or whatever device you consider safest, and just have distribution of your assets in case, because if you leave it in an exchange, there's the risk that that exchange can be hacked. It has happened before, and it has happened to large exchanges. So maybe you don't want to put all of your assets in an exchange. But if you leave it entirely to your own control, if you risk losing the seed phrase, then you have a different kind of problem. So we are all learning how to use technology. I would argue that it's still the very early days, and we are barely beginning to understand how to build products that gain traction and can be used, and what kind of products actually make sense with this type of technology.
And so what I understand is that there's still some development needed, and particularly if you're putting this in the hands and responsibility of the end user. Now there's another use case which I think it's amazing, because I think it applies, or you can apply blockchain directly, which is roaming. So the way that the operators connect with each other for roaming is in a peer-to-peer fashion already. However, there's still a big challenge and the possibility of roaming fraud, in the sense that there's a mismatch in time between the user using services in a network that is visiting, and the time that those services are charged to the home operator, and when they verify if the user can use or not those services. So that's one of the big problems. Now, the fact that this is peer-to-peer already by nature, and the fact that we're talking about service providers that are more educated in terms of cryptography, would you say that this would be probably the best place for the operators to start with?
I think it's actually a very interesting place indeed. Blockchains are fundamentally clocks. They are time-stamping devices. Each block contains a series of cryptographic proofs that have to demonstrate that happened the instant after the previous block, right? And when a block becomes verified by a miner, that certifies that the cryptographic proofs contained in that block, these proofs are obviously transactions between Alice and Bob. The miner, once that verifies that, timestamps, usually with a UTC or a standard signature for the date and the moment in time. In the case of Bitcoin, the blockchain timestamps on an average every 10 minutes. These 10 minutes usually contain a little bit over 1 megabyte of transactions, of proofs, and usually you will get 6 blocks per hour, and once the miners verify each block, they earn a subsidy in Bitcoin for providing the computation that secure the transactions on the network. In the case of Ethereum, blocks timestamp every 15 seconds. It's a faster blockchain. While Bitcoin handles 6 transactions per second, Bitcoin does around 20, 25. So the idea of using the blockchain layer for verifying the timestamp or the moment in time, so you can improve the syncing between participants in a peer-to-peer network, makes plenty of sense to me. It's a great place to go to that kind of consensus. There are some technologies out there that try to use the blockchain for notarization, for certification. Actually, 5 years ago, when my daughter was born, I did a small video and I hashed that video with a cryptographic key, and that hash, I included it in a Bitcoin transaction. And once the Bitcoin transaction was included in a Bitcoin block, that block contains that hash. So I can demonstrate that the video of my daughter, the bytes of that video, match with a hash that was chained to the blockchain. And so I can tell that that video was effectively shot in that moment in time, and that the contents of that video have not been corrupted. So that video works as a way of proving that the veracity of that content for that specific moment in time. So it is an incredibly reliable technology for that, because the clocking of the chain, it is a consequence of an incredibly complex process of cryptographic computation that is securing the network and preventing that there are that no single actor in isolation can tamper or can reverse or can change the immutable nature of the blockchain itself.
So that's very interesting, and I was just thinking, because you mentioned in terms of blockchain performance, in terms of transactions per second. Now, if you look at the telecom space, in particular mobile networks, and still on the roaming environment, we have millions of customers all around the world roaming, and that might result in an immense number of transactions per second. Do you think that the blockchain networks have the capacity to process all of those transactions, or do you think that there's going to be a bottleneck and they cannot scale if you deploy them in this type of environment?
So I would argue scalability is the #1 priority today for the development community trying to push these networks further. 6 transactions per second for Bitcoin, 20 transactions per second for Ethereum, transactions every 15 blocks, every 15 seconds or every 10 minutes. It's not incredibly scalable. Just to give a reference, the Visa network every Christmas, which is probably the peak season for Visa, does around 2,000 transactions per second. And the NASDAQ on a daily basis does around 10,000 transactions per second. So there's still a lot of room for improvement. Now, how can we scale this incredibly complex distributed computation that tries to achieve a consensus through players distributed around the world agreeing on what block comes next. Turns out that it's not that easy. You can do it by increasing the size of the blocks. That was a famous debate happening in Bitcoin. Just allow more data in each block in the blockchain. But if you increase the size of the blocks, the ability to participate as a miner or as a full node in the network also becomes more exclusive, because it means that you will need better computers, more storage, more broadband, more resources to become a full participant in the network. So that would be a centralizing force. Increasing the size of the blocks would only mean that only a handful of people in the long run would be able to serve the entire network. So keeping the blocks small was an important battle, actually, that happened in 2017 that led to the fork of Bitcoin. That's another interesting thing about blockchain, is that its governance is not zero-sum. Those that disagree with the idea of increasing blocks can simply fork the code, since it's all open source, and create their own set of rules for what they consider the valid version of the network. So it's non-exclusive and non-zero-sum, the kind of governance. Obviously, most of the value will be probably often tries to go where the majority is. In the case of Ethereum, Bitcoin tried to scale through the idea of using payment channels, which is a second layer network where you connect two users that agree to trust each other, and this user decides to trust someone else, and it starts routing these networks of trust. And these users, as long as they trust themselves, they can seamlessly trade their balance with each other at the speed of light. But then at a certain moment, they have to liquidate that balance and go back to the chain when they want to leave that second layer network. This was the approach led by the Lightning Network in the case of Bitcoin, which is a very well-known project. But in my opinion, so far, it has, after 4 years since the paper and the implementation and the mainnet, still has a very low volume of economic activity, and the usability has not proven to be very friendly for the end users. There's just not that many users. In comparison to something like Ethereum, Ethereum is growing in users. Most of the activity is still on-chain, but because of the fact that Ethereum is programmable, Ethereum doesn't only allow the idea of doing payment channels like Bitcoin, that's also a possible idea on Ethereum, but because of the programmability of the base chain, you can also include other mechanisms of verification of transactions in large batches. So there's now a race to create what is known as rollups, which are different techniques of batching a significant amount of transactions happening on a second layer, but you use the base chain for the data required to verify those second layer transactions. Most rollups are still in an experimental phase right now, but it does seem to be a more promising idea for scalability than payment channels. That said, Ethereum is also a network that is willing to trade some important pawns in its dynamics. It is willing to change its consensus algorithm. Ethereum is now transitioning towards Ethereum 2.0, and Ethereum 2.0 is changing the proof of work a consensus algorithm for a proof of stake consensus algorithm. Proof of work is very intensive in computation. You have to demonstrate that you have used a certain threshold of computing capacity. So as it becomes an arms race, it becomes a race for who can spend more energy burning to mine Bitcoins. Whereas with proof of stake, if you are a token holder, you can act as a validator in the network without the need of having to burn energy. That also means that those who have large stakes have more benefits in the network than those that do not have large stakes in the network. So it has a trade-off. But I would argue that Ethereum is taking whatever step necessary to reach in the short term 100 transactions per second with proof of stake and rollups. And eventually, as Ethereum 2.0 unfolds, the calculations aim to create a network that, when you combine proof of stake, rollups, and some other techniques like sharding, that you could have a network that could reach up to 5,000 to 6,000 transactions per second. Now, the transition from Ethereum 1 to Ethereum 2 means that it's also a transition of billions and billions of dollars in capital from one network to the other. It's not a minor achievement to do that kind of migration, and it will take probably 2-3 years from now until we'll see the full unfolding of this new network. And at least what we see now is that developers are very cautious with every change, and there's a lot of scrutiny. There's 7 clients being developed. There's a very strong community auditing every single step along the way. But it is again still early days. Scalability is still a major problem. There are some strategies that we can explore. Bitcoin has chosen the strategy that can choose with its limited capacity in terms of computation, but also an incredibly secure network. And Ethereum being more computing friendly, it is daring to do more interesting innovations on every part of the spectrum of what can be done with this type of networks.
Okay. And coming back to the telcos use cases, and we were discussing about how they could improve their current environment and operations. But one of the other topics that telcos are always looking is, can blockchain be the technology that allows me to generate new revenues, to roll out new services that me as a telco combined with blockchain that I could lead in the market? Do you see some obvious use cases or potential use cases for the telcos to adopt and sell a service tied to blockchain?
I think that the main attractor of ultimately these networks in terms of value capture is the idea of disintermediation. The telcos are in a very critical point, right? It is making sure that my phone has a soul, right? My phone, without having access to the internet, I feel lost. My life has no meaning. And thanks to the miracle provided by the telcos, suddenly my phone comes alive with my social life and everything. So telcos will always be sitting in a very strategic point of action. Now the challenge is, I would argue, for those services that mostly rely on the client-server architecture, as mostly being big tech, social media companies, communication companies, chatting companies, could those be disrupted by this type of technology due to the disintermediation and the benefits in privacy that these new networks bring? Assuming that these networks can scale in the future, how would that change the landscape of telecommunications? I think there's for instance, privacy, I think is a very, very hot topic around the world right now, and people wonder, are our messages in WhatsApp secure? Companies have gone out there to claim that they do end-to-end encryption, and that the encryption happens at the local level in the telephone. But would there be a master key behind WhatsApp, or is there a master key behind even services that are run by non-profits that care about privacy deeply, like Signal, for instance, which is a well-known chat messaging services built by a non-profit, claiming that it will only, in the case of the only piece of data that they store in their own database is who has called who, not the contents of the conversation. But even so, the who has called who, the metadata, sometimes is all you need in order to track the activity of a person and to target advertising or something related to attacking privacy. So how can we productize the potential of cryptography in a way that preserves the rights of users and disrupt this client-server architecture that has been running most of the internet products for the last 30 years? I think that that's an open-ended question. But for instance, imagining new identity systems that do not necessarily rely on personal identifiable information, that can enable people to connect with each other in a way where only those that are willing to connect with themselves are aware of who is, of how that connection is happening or who is talking to who, and no one from outside the network or from outside that connection, from outside that peer-to-peer relation. Or also ways of trying to monetize data that we generate on a daily basis, in our devices, and we want to make sure that, maybe we want to monetize that data. Today, that most of that data is monetized by the server. Almost 100% of the data we generate is monetized by the server. But if I had the means of proving that my data is mine because I can hash it, and I can demonstrate through the hash in the blockchain that I have generated those assets or that information, enable the monetization of data for the end user. And maybe that could disrupt business models around telecommunications. Use your phone for free and don't pay for your phone bill. And you will be able to provide your data to the networks in a way that you are not revealing who you are. You're just revealing a hash version of your data. And we are, I'm speaking out loud here, but those could be some roads, some avenues that could be explored on how the merge of crypto and telcos could lead to a change in the landscape of the businesses around data.
Yeah, very interesting. And what about things like IoT, so Internet of Things, which is becoming very hot topic, particularly with the rollout of 5G networks, which have the capability of connecting massive amounts of machines. And many of those machines, when you look at use cases like Industry 4.0, which is about having the industrial machines communicated with each other through a mobile network. Do you think that there are more possibilities there to apply blockchain and secure those communications? There will be more, at least potentially in nature, will be more peer-to-peer communication.
Definitely, we are going through an explosion in communication, right? And we have witnessed this. Anyone who has been in computing long enough, and we try to gain some perspective of what has happened over the last 10 years or 20 years or 30 years. It's pretty wild. And if we use that to extrapolate what's going to happen in the next decade, it's going to be even wilder. And it tends to accelerate. 5G, IoT, what kinds of new technologies that those will bring about, we can widely speculate, but probably not even our imaginations are the limit to those. I would argue that, moving forward, I would argue that the next decade, this decade, 2020, especially since COVID, where e-commerce, the way we are doing conferences today, the way we are doing meetings today, everything has been severely disrupted in favor of information technology. The markets are also clearly signaling. I look here because I do have the charts on my other screen here, but the markets are clearly signaling that we are having a transfer of wealth from the banking protocols to the crypto protocols. I would argue that the most salient fact of the American election last week was the fact that Bitcoin went up as the presidential race remained undecided. And that tendency, that pattern, seems to be consistent with other events in history. So I think that eventually it will become an important matter to design products around with these primitives that crypto is providing. I would find it, if you want to have an edge, if right now you want to find an opportunity someone hasn't explored in the market that could lead to an innovation that has the benefit of pioneering a new frontier, a new possibility of what's possible with digital technology, I would argue that crypto will become mandatory for the design of those products, and it definitely represents a tremendous opportunity for telcos. I'm not a specialist in IoT or 5G. I'm aware of the incredible relevance, and at the center of it, the remote control of everything is probably going to be our phone. So the main risk that the consumers will have is, am I safe at home? Is Alexa hearing my conversations? Is how can I trust technology? And that trust will not be a consequence of a powerful brand. Facebook or Apple are incredibly powerful brands, no doubt about that. And I use them. I can't escape them. But that's just not good enough to enable my trust to technology. What I do trust Bitcoin, or I do trust Ethereum, but I don't trust them because of the power of those brands. I trust them because I know how the technology works, and the fact that they have this Lindy effect, where the more these technologies remain out there without being hacked, without suddenly doing a rug pull and disappearing with our money, the more time spent like that, the more increases the trustworthiness of using mathematics and decentralized, distributed cryptography instead of centralized brands and the promise of a charismatic leader. That's the real battle going on here.
So that's potentially one of the opportunities for the telcos, right? To be that trusted partner in this digital era and ensuring that the customers are as protected as possible and in control of their data and their communications.
Absolutely. I think it's a responsibility also for the telcos. They are a critical point of the global infrastructure. And I think customers are willing. The question around privacy is an ever-growing question as we all gain awareness about how these technologies work. And when you want to buy an appliance and you probably did a Google search and you forget about it, and 10 days later or 3 days later you see an advertising on a social network, and then you wonder, are they reading my mind? That will only get worse. So if we want to make sure that in our homes, in our private places, in our safe places, we remain safe, crypto is the one tool that can help us gain the required defense mechanisms to remain safe. And ultimately, at the end of the day, cryptography is in fact labeled as a weapon under the US munitions list. It has been used for defense purposes, notoriously to beat the Nazis in the Second World War. But the interesting thing about cryptography is that it's inherently defensive. It's not a weapon to harm others. It's fundamentally a network to protect yourself. And I think that could also be argued that the American Constitution defends it in many ways, the idea of using this type of arms. So in that regard, I think that the software products, not only of the future, some of the present already are entering into that realm. Cryptography is a core component.
Very good. So we have 15 more minutes and we have a big list of questions. Nice. Let's try to cover as many as possible. Let me read them out to you and then you can give me your perspective. So first question is about if you apply blockchain to secure decentralized non-monetary transactions, e.g., for instance, a series of actions that are related but distributed across separate and independent systems and should be handled as an atomic operation. Do you need the mining function still?
No, I would argue that so non-monetary transactions, meaning that there's, for instance, there's a lot of operations that you can do without having to effectively execute a transaction and wait for the confirmation on the blockchain. You can sign operations with the blockchain. You use your private key and you have your public address, and you can sign a message and with that signature you can demonstrate that effectively that message is linked to a given public address, and that's just simply using signatures. And there is no need, as long as there's a hash produced, and then you can use that hash to compare stuff with other hashes, or whatever the design path might be for that particular technology. There's a lot of stuff that can be done without having to send an on-chain transaction, awaiting confirmation, executing a smart contract, which, by the way, using a smart contract is incredibly expensive. When there's actually, for example, in Ethereum, when you have lots of traffic, also with Bitcoin, a lot of transactions are happening, the price is going up, you start feeling traffic on the block. You want your transaction to get through, and you get this competitive market of fees being paid to miners to prioritize your transaction over others, and fees can skyrocket. I've seen in 2017 fees of, and I'm ashamed to say that I paid fees of $50 for a Bitcoin transaction, which is more than my bank probably charges me for a wire transfer or something like that. And I have in Ethereum, where we have this summer, a DeFi summer, where a lot of people were using different protocols. I ended up also paying $2-3 to interact with the blockchain, and that is a painful transaction. So scalability also goes in that direction, how we can reduce the cost of using the chain. Everything that happens on chain, we have to be aware that it is a costly thing to do, and it requires, you have to be utmost sure that it's a use case that requires using the chain.
Okay, thank you. And next question is about how master nodes change the perspective on blockchain generation and applications to different sectors, including telecoms.
So I think we covered a little bit of that in our conversation. It's definitely in favor of the end user, in favor of granting more privacy, finding ways of being able to, users will end up having wallets installed in their phones. It's a growing phenomenon. MetaMask or Argent or Jax, or I don't know, there's a broad range of wallets. Even traditional applications for finance like PayPal is now going to include crypto. Cash App or Robinhood or trading applications also include crypto. So everyone will be holding in their phones their wallet, and in that wallet, it's not only their stock, but also their assets, their crypto assets of any kind. And as crypto gets able to tokenize more and more things like real estate, so you will end up having that phone your certificates of property maybe, or investments, or all kinds of stuff. So how can you protect that? How you can guarantee that that remains in safe hands? How you can guarantee that that enables new services? I think it's going to be the wallet might end up becoming the next operating system, right? The operating system was the core thing in the 80s and 90s for this technology industry. Then it came the browser wars and whoever, Internet Explorer and Chrome, and well, then social media. What happened? The operating system had the browser inside of it, and the browser inside of it has search engines, and search engines has social media, and social media. Well, the wallet might be an interesting race to see looking forward at this, as these protocols become more important.
Yeah, that's a very interesting perspective. Another question is if you can help us understand how telcos can use blockchain to help preventing fraud. I think that we also briefly discussed that, but if you have some more to add.
Yeah, definitely timestamping mechanisms. Blockchains can be a third-party validator of events that happen throughout time, and that can help in the syncing. I would argue exploring use case around that would be very interesting.
Mm-hmm. Good. Another one is about which mechanism technology do you see more applicable to the telco applications, BFT, sidechains, or any other? So
consensus mechanisms are a very interesting topic. I would argue that the challenge for telcos is scalability. So I'd rather pay attention. Everything seems to point right now that, for example, Bitcoin, the main use case, the main narrative, its main thing is Bitcoin being a store of value. You just use it to store value because it's expensive to use it for anything else. So that means that the utility of Bitcoin for other use cases, because it's slow to transact, it's slow to the ability of proof of work. Bitcoin is ultimately the best implementation of proof of work as a consensus mechanism. Might be that proof of work is just simply a good guarantee to store value because of all of the energy that is backing the network, and that the fact that no single state or corporation can manage enough resources to gather the necessary energy to subvert or to revert or corrupt the immutability of the chain. So as a store of value mechanism, proof of work makes sense. For telcos, I would argue that probably it's better to look at other consensus mechanisms based on Byzantine fault tolerance, like as it was mentioned in the question. There are some BFT models out there that are being explored by other blockchains. These are very interesting projects, still not very popular in usage in comparison to Ethereum, but nonetheless are exploring different avenues. There is a project called Solana that is using a new model for BFTs. There's a project called Cardano, Cosmos, Tesos. All of these projects have variations, but ultimately they are some version of proof of stake. The conversation 5 years ago was proof of stake is the future after proof of work. Some maximalists would argue there's only proof of work. I think both matter. Proof of work might suit better for financial use cases, and proof of stake for all the rest. But looking at side chains might also help address the scalability issue in the short term. It's probably likely that in Ethereum 2 we will get proof of stake, which will increase the ability of validating transactions through the use of validators instead of miners. But the geography of proof of stake that Ethereum is building will be based on shards. So you will have 64 shards that can have transactions like these are sub-blockchains. And you will need to address these blockchains, these shards within the blockchain in order for the shards to communicate themselves. But for the network to remain optimized, you have to fraction the network into multiple shards. And that will increase scalability significantly. Numbers again go in the wild speculation, but I would say Vitalik himself has said 5,000 to 6,000. But it comes at the cost of introducing some complexity on how the calls are generated, how the addressing is built, and how the smart contracts talk to each other. It does not come at one of the virtues of blockchain networks is the composability. I have a smart contract here that can talk to a smart contract there in a permissionless way. And there's a lot of APIs, quote unquote, or oracles that you can build that way. But as you introduce shards, this composability becomes a little bit weakened because within the shard, the contracts can talk to themselves the same way. But if you want to talk to someone out of the shard, even though you're increasing the scalability of the network, it introduces complexity in how you write these contracts. That said, I've seen some interesting implementations of second layer technologies using rollups today. There's CK rollups, optimistic rollups. Those are some of the variants of rollups that could be useful. So in terms of scalability, I would look into rollups today. In terms of sidechains, you have sidechains there are some in Ethereum like proof of authority or XDAI that try to work as sidechains. Where again, these are like shards that have their own quick consensus happening within the participants in the sidechain, and then you consolidate in the main chain. There are some projects using XDAI today, which is an interesting sidechain, and POA, proof of authority, is another one. And on Bitcoin, you have RSK, Rootstock, which is it is a sidechain on Bitcoin to allow smart contracts on Bitcoin, replicating the Ethereum virtual machine on a Bitcoin sidechain, which is a very interesting project for those who want to use Bitcoin as collateral. But in terms of scalability, I would argue that today Ethereum is in the pole position, mostly because the demand for it is incredibly big right now, and the development muscle is there.
Mm-hmm. Very good. Now we have another question that brings back to the example that you gave about video. And the question here is, there's a growing concern about deepfakes propagating. So do you think that blockchain is the solution to protect, and how would you address it?
Deepfakes, fascinating topic. There's a favorite website of mine. I actually use it on presentations called This Person Does Not Exist. And it just shows you a picture of a face that has been generated by a GAN, a generative adversarial network. This is a version of deep learning neural networks that learn from each other and compete with each other. And as they learn from each other, they can learn the attributes of what makes a human face, and they can replicate new faces out of that data. And when you look at the pictures of This Person Does Not Exist, all of them look realistic to me. You have to have a very, maybe in the hair you might detect a weird pattern, but 9 out of 10 people will not get the fact that these are fake humans. So this only promises that as Moore's law keeps happening, computation keeps becoming cheaper and cheaper, more abundant, more available, that tomorrow these will be videos, and these will be voices, and this will be everything. So our reality is breaking apart. We can no longer tell what's true anymore. And this is a consequence of abundant information, of information society. The only recipe I can think of for very effectively making sure that whoever is on the other side is the person I believe who is on the other side is definitely the road of using cryptography in this way. Otherwise, if we didn't have, I guess it's almost Hegelian synthesis. You have the enemy that's going to destroy reality, deepfakes, neural networks, AI, and at the same time you have the solution that is going to fix that, or the other way around, regardless of your ideology. But it's Hegelian synthesis in the sense that it's a dialectical process, and every new technology creates both the oppressor and the oppressed.
Exactly. Yeah. Very good. Thank you very much. We're on top of the hour. This was a very interesting conversation, as always. Really appreciate talking to you and your enthusiasm and knowledge in this topic. I hope we continue having these conversations. And I also would like to thank all the attendees to this webinar, and thanks for the good questions.
Thank you very much, Rui. It's been a pleasure, and I learned a lot about the telecommunication industry preparing for this.
Yeah, I'm glad that we're both learning as we talk. Very good. Thank you very much.